Chapter 6: Estimation Procedures. Today, we will give the public a brief glimpse into the behind the scenes of our surveys using SPSS for Windows to produce confidence intervals with the 2006 census. The 2006 census essentially provides a snapshot of the diverse characteristics of the Canadian population. PLA Marketing Group. We are a marketing firm from Hamilton, Ontario called PLA Marketing, and our main job is to market the Global 13 phone to students at McMaster University. Professor Alway of Statistics 3N06 has asked us to show his class how to use confidence intervals when we are marketing our Global 13 phone.
So we are part of the PLA Marketing Group. We established in 2013, composed of 3 young entrepreneurs producing a smartphone for the new century. And our smartphone is called Global 13. We're using this phone to utilize estimation procedures to display cell phone use in the McMaster population. For example, if we know that 65% of a random sample drawn from McMaster use their cell phones on a daily basis, then we can estimate the percentage of all the students who use their cell phones on a regular basis. So, what is a census? A census is an official count or survey of a population, typically recording various details of individuals. For example, it can include household income groups or retirement pensions. In particular, we will be looking at the total income levels of individuals and the legal marital status of Canada in 2006. We will link our cell phone market to these variables, and looking at a census of the past will help us to market Global 13 to future customers. So when looking at the total income levels of individuals, we would be able to tell whether or not they could afford a cell phone. So confidence intervals. A confidence interval is a type of estimation procedure which consists of a range of values, an interval, instead of a single point. For example, between 85% to 90% of McMaster students use a cell phone daily. Thus, we estimate that the population value falls between 85% and 90%, but we do not know the specific value. So, how to construct a confidence interval. The first step in constructing a confidence interval is to decide on the risk that you are willing to take to be wrong. An interval estimate is wrong if it does not include the population parameter. The probability of error is called alpha, represented by A. The exact value of alpha will depend on the nature of the research situation, but a 0.05 probability is commonly used. What does a confidence interval mean? Setting alpha equal to 0.05 is also called using the 95% confidence interval, meaning that over the long run, the researcher is willing to be wrong only 5% of the time. In other words, if an infinite number of confidence intervals were constructed at this alpha level, we would be examining 95% of the population and 5% would be excluded. So these are the commonly used alpha scores and corresponding z-scores for our PLA Marketing Group, but there are also common z-scores for anyone who's trying to calculate a confidence interval. This is the formula used to calculate confidence intervals. Ci equals x bar plus or minus z times sigma over the square root of n, where x bar equals the sample mean, sigma the population standard deviation, z the value for the desired confidence level, A obtained from the area under the normal curve table. Click Analyze, then Descriptive Statistics, then Explore, then scroll down to find Total Income of Individual. Click on it and move it to the dependent list box, then click Statistics, and you could change your confidence interval to 99% or keep it at 95, which is going to be used for this demonstration. Click Continue, then click the display box and click on Statistics. Click OK, and your output is produced.
The error bar graph. It is a confidence interval of a sample mean can be represented using a graph called the error bar. So what is an error bar graph? Error bar graphs are a graphical representation of the variability of data and are used on graphs to indicate the error or uncertainty in a reported measurement. They give a general idea of how accurate a measurement is or how far from the reported value the true value might be, based on the lower and upper limits of the confidence interval of a sample mean. So how to construct an error bar graph? First, the sample mean is plotted with a symbol at the center of the graph. Second, a vertical line, which can be called the error bar, is drawn from the sample mean to the lower limit of its confidence interval, marked by a horizontal line. Third, you would repeat for the sample mean and the upper limit of the confidence interval. Last, make sure the area bordered by the two error bars is equal to the width of the confidence interval of the same mean. Here we will produce an error bar graph for the confidence interval for the mean of total income. So click Graphs, Legacy Dialogues, go down to Error Bar Graph. We're going to use Simple with summaries of separate variables. Next we will find the total income, and we just put it into the error bar graph. We'll use confidence interval for mean at 95%, and that will produce the error bar graph.
Okay. Next, we will demonstrate generating statistical information for use in constructing confidence intervals for sample proportions. Basically, the only difference here is that we will use proportions of the population parameter rather than the means of population. Unlike the Explore procedure for constructing confidence intervals for the sample means, SPSS does not provide a program specifically for constructing intervals for the sample proportion. However, we can use SPSS to calculate the sample statistics, namely proportions, on which interval estimates are based. Once you know these simple sample statistics, the confidence interval for the sample proportion is easily computed. Constructing confidence intervals for sample proportions. If one is using a sample proportion to estimate a population proportion, one can use this formula. Using SPSS, I will find the confidence interval for sample proportions. To do this, we click Analyze on the menu bar, Descriptive Statistics, and Frequencies. Scroll down to find MIRST or marital status and move it to the variable box. Then press OK and you will find this table. In conclusion, estimation procedures are a type of inferential statistics that help political social scientists to estimate population parameters from statistics computed from samples. It is important to remember that these procedures do not include everyone in the population, and there is a margin of error in which one can gather their statistics from.